Tonight you have homework. This worksheet you got on Monday. It's going to be due tomorrow. We're going to check it in class. So this is what we did in class. We talked about using Pythagorean theorem because the tangent is perpendicular to the radius. These numbers change, so you have to so this was the front page that we did in class. And then we proved on the very last part. So it just kind of breaks down the back is what you're having to do. So I'm just going to kind of make sure you understand that 1, 2, and 3, the numbers are going to change each time. But AB is going to be the first number, which is 2. That's our radius. CD is the part outside. That's the 3. But AD right here is also a radius, so that's 2. So that means that the whole hypotenuse is 5. They want us to find BC, which is that leg. So to set it up, we should be doing basically 2 squared plus x squared equals 5 squared, which gives me 4 plus x squared equals 25. And then I'm just going to go over here, subtract 4 from both sides. X squared equals 21. And then we're going to subtract, I'm sorry if you didn't see that, I minus 4 first to get that there. And then we're going to take the square root of 21. You're going to need to, this is not a perfect square, so you're going to have to round to the nearest tenth. And I believe this one was 4.6, I believe. Square root of 21. Yeah, 4.58, which is approximately 4.6. All right, so when you do number 2, if you want to redraw it, you can, but we're going to have to relabel because now the radius is going to be 4, so the same radius is 4. The external part of the hypotenuse is going to be 3, and we're still finding BC. So we're going to do 4 squared plus x squared equals, and our hypotenuse is 7 squared. So when you work it out, we get 16 plus x squared equals 49, minus the 16 on both sides. I'm going to move it over here. So this leaves me with x squared equals 33. And then you're going to take the square root of 33. Take the square root. So that leaves us x, that's one again, x is approximately 5.7. So try to do number 3, same way, plug it in, use Pythagorean theorem. Then when you get to this section, this is cone head. This is what we looked at yesterday and today in class. The numbers are going to change each time, but we're going to use the cone head theorem to find the additional parts. So PQ, that's the first segment, that's 3. That means just from P to Q. QR, that's our second segment here. That's going to be 2. And TS, the third one, TS is here. That's going to be 4. So I probably should have just broke this down one at a time. So if PQ is 3, then PT is also 3, because those are both tangents from the same point P. And if QR is 2, then R, and I know there's not a point here, but basically here it would also be 2. And if TS is 2, or 4, excuse me, then across that other tangent is also 4. So here we're going to add, to find the length of our S, we're just going to say 2 plus 4. I didn't write that very well. And we get 6. So each time we do this, if PQ is 4, and then PT is 4. If QR is 3, then this little part here as well is 3. If TS is 2, then the other tangent is also 2. Now I know you see a pattern now, and I know you can get the answer without getting the pattern, but understanding that the opposite part, that the tangent coming from the same point, is going to be the same. You're going to need to be able to label like I'm doing to get to your answer. So yes, this is 5, and I know you can see the pattern and get to 6 to get that answer. Now, here they tell us that segments shown are tangents, and they've already showed that they're perpendicular to the radius. They put the box already there for us. So they want us to find, given we know PQ is, PQ and SZ are 4. Okay, so that should be a 4 and a 2. That doesn't look very well. PQ is going to be 4, and SZ It's going to be 2. All right. So SC is your radius. So if you notice, SP is also a radius. So automatically, with no math, knowing that all the radii are congruent, that's going to be 2. Now, to find the Q, which represents the hypotenuse of the right triangle, you're going to have to do Pythagorean theorem. So we should be doing 2 squared plus 4 squared equals the Q squared. So 4 plus 16 equals Q squared. We get 20. It's Q squared, but then you have to take the square root. So it's a decimal answer because that is not a perfect square. So when you take the square root, of 24.5. And then our last section, you have to determine if it's a tangent. If it's a tangent, then the Pythagorean theorem will work. So if it's a tangent, basically we're just going to show that a squared plus b squared would equal c squared if it's a tangent. So I'm just going to label the given parts. OJ is 3, and then JK is 4. OK, that's the whole segment, is 5. Did we do this one? It seemed like I did this one. And then we're going to do Pythagorean theorem. So does 3 squared plus 4 squared equal 5 squared? Well, that's 9, 16, 25. 9 plus 16 equals 25. So this equal each other. That's true. So this one would be true. Yes, it is a tangent. And then we're going to do the same thing on 10. JG is the diameter. The radius is 36. So that means that the diameter, this whole thing, will be double that. So that would be 72. And then PG is 77. JP is 85. Again, I know they're big numbers, but just do Pythagorean theorem. 72, use your calculator. 72 squared plus 77 squared, does that equal 85 squared? No. Hold up, let's put it in there. 72 squared plus a 77 squared is a sum. Delete that into a 1, 3, 3, and then 85 squared is 7225. So this does not equal each other, so this is false. Alright, so the ones that didn't complete, you need to complete. Make sure the front and back is done. It should be an easy grade. Be ready for your check tomorrow. Thank you.